Now let's talk about the general multiplication rule. And again, the general multiplication rule helps us whether events are independent or not independent. So previously we only looked at independent events. Now we're going to look at events that are not independent. So previously we used this formula. We said, okay, if they were independent, we could just take probability of A times the probability of B. And when the trials were not independent, now we're going to have to use a concept that we just learned about. And that says, find the probability of A, multiply it by the probability of B, but assume that A already occurred. Now, the good news is, if they're independent, it works, and if they're not independent, it also works. So let me give you an example. I have 10 marbles in a bag, 3 orange, 2 black, 4 yellow, and a red. I'm finding the probability of red and the probability of black. So probability of red intersect black. And a lot of people get confused because intersect means a different thing when we're looking at an addition question than at a multiplication question. They're the same concept, but a little bit different. So just kind of keep them separate. So here I say the probability of red is I have 10 marbles and one of them is red. So the second time I have to find the probability of a black, but I have to assume that I've already chosen the red. So this red is gone, which means I only have 9 marbles left in my bag, and 2 of them are black. So this is where this little nugget will come into play, because I have to assume that A has already occurred. So then I would multiply, or I prefer actually to reduce before I multiply. So I'm going to divide each of those by 2. And then I'll end up with 1 over 45. And then, of course, I can turn 1 over 45 into a decimal, going to 4 places, 0.0222. So that is the general multiplication rule. So let's take a look at a few more practice. This one's dealing with the standard deck of cards. Again, remember that there are 4 suits. There are 13 cards per suit. There are, I don't know that they ask about face cards, but remember there's 3 face cards per suit. So just in case you don't, play cards and you don't know these fun little statistics. So I'm selecting 2 cards from my standard deck of 52 cards. Oh, I guess I should have said each deck has a 2, 3, etc. through 10, and then Jack, Queen, King, Ace, where the Jack, Queen, King are the face cards. So each suit, which are hearts, diamonds, clubs, and spades, are the 4 suits, where hearts are red and diamonds are red, and I do have a black marker, and a club is black and a spade is black. Okay, so tutorial on a deck of cards is over. Let's look at probability. I'm selecting 2 cards at random from a standard deck of cards without replacement. And without replacement just says I'm going to take the first card out and I'm not putting it back in the deck before I pick the next card. So what is the probability that I select 2 kings? So I'm finding the probability of king and king, which means I'm finding the probability of a king times, and again times because it's 2 events just like before, but instead of just probability of king, I say the probability of a king, assuming that I've already pulled a king out of the deck. So which means the first time I have 52 cards and 4 of them are kings, and yes, I could have written that in a reduced format, but I'm just going to leave it like this for the sake of knowing how many kings, how many cards. The second time I have already pulled a king out of the deck, that's the given, which means there's only 3 kings left. And because I've pulled a king out of the deck, there's only 51 cards left. So then from here I would do a little bit of reduction. 1 out of 17, and of course 1 out of 13. And then I would multiply these to get 1 out of 221. And that gives me 0.0045. So let's look at our next example. We're still drawing 2 cards, which means we're still going to be doing some multiplication. Standard deck of 52 cards without replacement, just as before. The probability of selecting a 2 and a jack. So it's probability of 2 and a jack, which means the probability of a 2 times the probability of a jack, assuming I already pulled out the 2. So from here, I would say that the probability of 2 is that there are 4 2s, 1 in each suit, out of the 52 cards, just like I had before. And the probability of a jack is that there are still 4 jacks in the deck. I didn't take out any jacks this time. I only took out a 2. But there are still only 51 cards because I took out one of the 2s. So again, I can reduce a little bit first before I multiply if I want to. And then I would multiply and get 4 out of 663. And that gives me 0.006 as my solution. So let's test your knowledge and see how you do on this last question, or I guess 2 questions. And go ahead and see if you can do them both, and then press play to see how you did. Okie doke, let's look at the first one, the probability that both are women. So here we've got 4 women, we have 3 men, that means 7 total when I start with. And they're randomly selecting 2 people to attend a conference in Hawaii. Please select me. The probability of a woman intersect woman, which means the first one is the probability that a woman is chosen. The second one is a probability that the woman is chosen, assuming that I've already chosen one of the women. So the first time I have 4 women out of 7 total people. The second time I only have 3 women because one of the women is already packing her bags and getting ready for Hawaii. So there's 3 women left, and there's only 6 total people left because, again, that woman is no longer in the running. So again, you can certainly choose to reduce anything you want ahead of time before you multiply. That would give me 4 out of 14. So again, I could have reduced even more if I wanted to. Either way, I don't really care about the fraction. I'm looking for the decimal. And in this case, it would be 0.2857, or about 28.57% chance. Now, what's the probability that they're both men? So let's take a look. Probability of man intersect man. And this should be a little bit less of a probability because there's 3 men. So the probability of me choosing 3 out of 7 as opposed to the 4 out of 7, this probability should be lower. So again, this is the same idea. Probability that I choose a man times the probability that I choose a man, assuming I've already chosen a man to go. So if the first time there are 3 men out of 7 total, the second time I've already chosen a man. He's calling people to let people know he gets to go to Hawaii. And there are 2 men left, but there are only 6 people left. And again, feel free to reduce as much as you'd like ahead of time. Here I get then 3 over 14. Nope, that's not true. Not 3 over 14 because this should have been a 3. My bad. So this is actually 3 over 21, which means I could have reduced a little bit more. But again, don't care about the fraction. I care about your decimal, and your decimal is 0.1429. And that is my final solution. So again, it was about half of the probability of choosing 2 women.